Здравствуйте, привет. Меня зовут Brad Fitzpatrick. Большое спасибо за приглашение на GopherCon. Это мой первый GopherCon в России. И ваш тоже, да? Добро пожаловать. В течение 8 лет я работал в Google на языком Go. Сегодня я расскажу о прошлом и будущем Go. Сначала, кто не знает по-русски? Все. Отлично. Кто хочет, чтобы я говорил и дальше по-русски? Поднимите руки. А вот и нет. Я американец, поэтому я говорю только по-английски. Но моя жена говорит по-русски, и мой сын будет говорить по-русски. И он будет говорить лучше, чем я. У кого есть дети? I'm sorry. I'm sure your kids are great. I'm sorry for the bad Russian, though. And sorry for all the baby pictures. I can't really help it. I'm now that guy who shares baby pictures. He's 7 months old now, and he's absolutely wonderful, but he's also like absolutely exhausting. And I have like fond memories of a time in my past life when I used to be able to sleep. And sleep was very nice, I think, I remember. So if I could draw kind of like a picture of my life and the eras of my life, I was just thinking about this. In the first phase of my life, I was a child and I went to school, and I did this for about 22 years. And then I graduated, and I never had to think about going to school again, and that was very great. Then I entered kind of like the party phase of my life, where I worked hard and I played hard, and I traveled a lot, and I could just get on planes and go wherever I wanted, and that was very nice. But then I met my wife, and as these things happen, we had a kid. And so now I change a lot of Puguzniki, and it turns out that there's no diaper emoji, so I had to be a little explicit here, but that is my life now. And I don't really know what comes next. I can make some guesses. Maybe I will just drink myself silly and die. Hopefully it's more exciting than that. So really I have no clue, but yay, I'm excited to see. But this is a talk about Go, and not a talk about me. So I wanted to talk about the eras of Go's life. And if I could draw Go's life, I would kind of bucket it into 4 segments. I'm going to call them the Protozoic, then the Cambrian explosion, the Mesozoic, and we're now entering the Anthropocene. And so I will talk about each of these 4 phases of Go's life. Starting with the first era, Go's Protozoic. And in this beginning, Go was a prototype. It was kind of a simple life form. And it worked, but it wasn't exactly what you would recognize today. And notably, it was a Google internal prototype, which is not a very interesting place for code to live for most developers who are not at Google, which is most developers. Go was started by these 3 people. This is Robert Griesemer, Rob Pike, and Ken Thompson. Robert Griesemer is known for like Strongtalk and Hotspot, the Java compiler, and then runtime VM. He also worked on V8, so he knows a lot of like kind of higher level languages, and he's really good at like, and they all like have very different backgrounds. Rob Pike worked on Plan 9. He did UTF-8 with Ken. And Ken, was just like invented B, which became C, and he like made Unix and UTF-8 and Plan 9. So they all have like very impressive backgrounds, but they're all very different backgrounds too. So Rob Pike did a blog post recently called Go 10 Years in Climbing, where he kind of talks about the early history of Go, and he has a bunch of good quotes in there. And he says at one point that the initial discussion was on the afternoon of Thursday, the 20th of September. It led to a meeting between us at 2 p.m. the next day. And this happened because they were at a presentation about C++ and all the new features that were coming in C++ 11. And they were just so offended that the language was getting bigger and bigger and more complex. And they were so disgusted by how slow their builds were at Google. They would try to compile a server, and it would just take forever. So they had a lot of time to daydream about what their like simple language would look like. But anyway, this gives us the beginning date for the first era of Go, September 20th, 2007. So this is the first date. And the name came about 5 days later. Rob Pike mailed out and he said, okay, I had a couple thoughts. First, the name. And he says, you know, it's short, has nice properties. The suffix can be Go. The tools could be GoC, GoL for GoLinker or GoAssembler. The very first commit in Go was actually the spec. So they didn't start writing code, they started designing, you know, what it would be. And this is the one thing I like about Go, that it's defined by a specification rather than just a de facto implementation like many scripting languages. It also had, one of the early properties is they decided that all things would be based on consensus among the three of them. There's this quote from Ken where he says, when the three of us got started, it was pure research. We decided we hated C++, and we started off with the idea that all three of us had to be talked into every feature of the language, so no garbage would get added. And this is important because all three of them have very different backgrounds in computer science, and they all have very different preferences about what they like and don't like in languages. So if something got in, it was actually really hard to get all three of them to agree. So the very first actual Go code that got checked into the repo was this unit test. And it kind of looks like Go. GoFumped didn't exist to format the code, and there's some semicolons in there that are a little weird. But the first standard library package was the FMT Fumpt package. Some people pronounce it format or FMT, but most people on the Go team just call it Fumpt. It looked a little bit different than what you see today. Notice that there's the uppercase, lowercase thing for exported versus unexported identifiers didn't exist, so there's this export keyword. And look how you would use the package. You like do fumpt.new, and you make, so all the things you know about fumpt are totally different. A month or so later, this guy Ian shows up out of the blue, and he writes to the mailing list and says, hey guys, I saw your little language, it's cute, I made a GCC implementation. And it totally surprised everyone on the team that there was a new implementation of their language, and they felt very good about that. So the GCC implementation of Go is called GCC Go, and the main implementation of Go is called GC. It stands for Go compiler, because it's based on the Plan 9 compiler called CC, which stands for C compiler. But don't confuse little gc with capital GC, because this means garbage collector. So you can make sentences like C, GC or GCC Go mostly share the same GC, G. Got it? So there was now a spec for Go, and in Go the spec is the truth. But now we had two implementations of Go. We had GC and GCC Go. And whenever they diverged in behavior and one of them did something differently than the other one, there was either a bug in GC, or there was a bug in GCC Go, or there was a bug in the spec. So whenever we found a difference between one of them, there were lots of new unit tests added, there were a lot of new fixes, or the spec was clarified. Anyway, the goal is always to get back to this state where there's no differences between any of the implementations. So about 7 months after they started hacking on the language, they did this internal tech talk in Google, and at this point Russ Cox had joined them, so there's now 5 of them on the team. And they said, you know, our goal is that building a binary should be fast, and on a few seconds on a single machine, because this is why they were frustrated by large, slow C++ builds at Google. And they said the language is concurrent, garbage collector, requires explicit declaration of dependencies, which is another problem we had at Google at the time. And it's a simple syntax, and they said, you know, it's not ready for production use, but we're starting to get a feel for what it's like to write in Go. So I went to this talk because I was just kind of curious what they were doing, but I didn't start using it yet. But 1 year after that presentation, about 2 years after they started working on the language, they open sourced it. So there was this blog post on November 10th, 2009, where now I was interested in it because open source, and I could actually use it. And my commute to and from Google was about, I don't know, sometimes 2 hours, sometimes 3 hours, sometimes more, depending on traffic. And so I had a lot of time to play on my laptop with a really, really bad internet connection. So I started playing in Go sitting on the bus. So I would say that this is the end of the Protozoic, and it kind of when Go gets open sourced. So this period was about 2 years. Now we're in the Cambrian explosion, or the open source era, which begins 2009, November. And during this time, during the 2 years before this versus the 2 years after this, we went from like 26 unique contributors to about 250 unique contributors. We went from one company using Go to multiple companies using Go. We went from about 4,000 commits in the repo to about double that, or more than double that. There were about 3,400 bugs filed, which was about 4 per day, even on weekends. The standard library was basically written during this 2-year period. I mean, much of it had existed, but it all changed. It was actually, the standard library and the compiler were changing every week. So if you wrote a program, the next release of Go would come out the next week, and none of your crap would work anymore. And so it was kind of an exciting but terrible way to develop software. You also, when you wrote Go packages in this time period, you had to write make files, and you had to list all your files and all the dependencies, and it was just terrible. So we killed that, and replaced it with the Go command that go install, go test, all that fun stuff, and not having to write make files. The error type used to be in the OS package for no good reason, and so it was promoted to be a first-class thing in the language. The rune type was added because it used to just be an integer to describe a Unicode code point, but we knew that integers were going to become 64-bit integers later, and we didn't want runes to waste all that extra space. So rune was added. The syntax for deleting from maps was changed. It used to be really weird. The time package was changed to have time.time and time.duration. It used to just be int64s, and it was terrible. And a whole bunch of stuff in the standard library changed. So about 2 years later, from this time, Andrew announced that we were tagging a Go 1 release. And the notable thing about Go 1 is that we were saying that it's intended that this will be a stable release in the long term, and we won't break you every week. Because it used to be that all your programs just failed every week, and you had to update to new APIs and new language changes. So we wrote some release notes. He said, hope you all enjoy it. Thank you, all the people who contributed. Tell your friends. Have fun, and tell your friends. So this ends kind of the end of the Cambrian explosion, which was just over 2 years. And we begin the Mesozoic. And Wikipedia says that the first animals also appeared during the Mesozoic, but would remain small, less than 15 kilograms until the Cenozoic. So I'm going to say that this is when gophers emerged in the Mesozoic, and I'm not a paleontologist, but I'd like to believe that this is when he appeared, and I'm not going to let the truth get in the way of a good story. So we're going to say the Mesozoic was the rise of the gophers. So this was the Go 1.x era that we're in now for it's been actually almost 6 years. And remember Andrew told everyone to tell your friends? And they did, and they told their friends, and Go has exploded in popularity in the last 6 years. So I like to call this the exciting and boring era. And it's exciting and boring all because of this compatibility document. Because we've promised not to break your code, and we don't break the standard library, we don't change the language, that means you can actually trust it and build stuff on it and deploy it. And the Go compatibility document, basically says this: we won't break you all the time. And if you wrote a program for Go 1, it'll continue to work in Go 1.1 and 1.2 and 1.3. So 2 years ago at GopherCon India, I gave a talk about introducing Go 1.6, and I called the talk Asymptotically Approaching Boring, where I showed this graph of the number of language changes over time as a function of the release. And if you look at it, it's kind of going to 0, and it's kind of going to boring. But that is just the language changes. And Go is many things. Go is the language and the standard library on top of it, and the runtime with the garbage collector and channels and maps. And it's the tools and the ecosystem. And only the language is frozen. The runtime and the tools and the ecosystem are all on fire still. So if you look at a graph of the language size over time, the language gets a little new things occasionally, like there were type aliases added recently, but generally the language is frozen. The standard library is mostly flat. It continues to get some stuff, but it's still pretty boring. But the number of packages on GitHub is out of control. The number of users is all over the place. The amount of C code in the Go runtime is now 0, which is great. As of Go.1.5, we don't use any C. Go is written in Go. The number of GopherCon conferences in Russia has gone from 0 to 1. So the compiler continues to get faster and generate better code and has all these SSA optimizations now. The garbage collector pauses continue to go down. There was this great tweet series a while back when Go 1.5 was released. This guy was looking at his production monitoring, and he was looking at his GC pauses for Go 1.4, and it was, all of his servers were around 300 milliseconds. And he deployed a canary with one machine running Go 1.5, and it drops down to like 38 milliseconds. So everyone was like, whoa, holy crap, that's amazing. And then Go 1.6 comes out 6 months later, and he's like, they did it again. And it drops from like 38 milliseconds to 2.5. And then they did it again in 1.7. And then they did it again in 1.8. And it drops from like 2.5 down to like 0.5. And he's very, very happy. He's like, sub-millisecond pauses, holy crap, on an 18 gigabyte heap. So the garbage collector continues to get better. And even in 1.9, 1.10, 11, the pauses are about as low as they can get. So now they're just tuning it and making it use less CPU. So we've gone down from like 300 to well under 1. The number of Go operating systems and architecters, the number of ports and platforms we support continues to go up. But first, some trivia. Who knows the official pronunciation of Go OS? Goose. What is the plural of goose? Geese. Sorry, it's not goosey. How many Go OS values, how many goose values are there, ignoring the extra ones added by all the other implementations? Any guesses? 8? I heard an 8. Do I hear a 9? Do I hear a 9? 20? That'd be impressive. There are 11. I will not ask you to name them all, but they are, the original ones were kind of Linux, Darwin, Windows, and FreeBSD. And now there's more BSDs, Dragonfly, FreeBSD, NetBSD, OpenBSD, Plan9 Solaris, Android, and native client, which is kind of like the old WebAssembly, maybe. Harder question. What is the official pronunciation of Go ARCH? Gorch. How many Gorch values are there? Guesses? 4, 7, 19? There are 12. And they are 32-bit and 64-bit x86, the weird native client one that's like a mix of them, 32-bit and 64-bit ARM, a whole bunch of MIPS for little endian and big endian, and PowerPC. And if you have a couple $1 million and you want to buy an IBM mainframe, you can now run Go on your IBM mainframe with S390X. I do not have one of those. How many valid combinations of Goose and Gorch are there? The upper bound is 11 times 12. Any guesses? 100, 40, 70. 40 was probably the closest. If you run gotool dist list, it spits out all the possible values, and there are 38. Although NetBSD ARM is broken right now, so maybe it's like 37.5. So we've gone we run on a lot of places now, basically. The tooling continues to improve. Compared to when Go 1 came out, we did not have the race detector. Props to Dimitri, wherever he is. Testing.pb for doing parallel benchmarks is new. pprof continues to get better for profiling. There's the cover tool, the trace tool, lintvet. Dominic's megacheck is awesome. So there's like a lot of third-party tools in the ecosystem now. For Go 1.11, there's going to be a view core thing to analyze memory dumps of live programs and dead programs. And the dwarf debugging stuff continues to get better. So the runtime, the tools, the ecosystem are on fire. The standard library is kind of bleh, as it should be. And the language is frozen, which is kind of a feature. So this is where we are now. We're kind of at the end of an era, at the end of the Mesozoic. But why do I call it the end? It's because Russ Cox at GopherCon last year announced that we're starting to think about Go 2. And there's not really an official plan yet, but we're talking about it. So we're at the end of the Mesozoic and the beginning of the Anthropocene. And this is the beginning of the Go 2 era. And why do I call it the Anthropocene? The Anthropocene is defined as the current geological age viewed as the period during which human activity has been the dominant influence on climate and the environment. So I'm going to change that to say on which gopher activity has been the dominant influence on Go 2.x in the ecosystem. You get it? That's because for Go 2, we really want experience reports from the community to say like what does and doesn't work about Go 1 and what would they want to change in Go 2. But we want like really thoughtful, proper bug reports that, not just like, give me generics or, change all of this. And so there's some examples on this blog post about like what we're looking for in terms of like analysis of why you would change something and how to do an official proposal to change something in Go 2. So just like my life, I have no clue, but yay. I'm excited about what Go 2 may or may not be. But we do maybe have some clue. We know the constraints about what Go 2 will not be, and we can make some guesses. So first, some constraints. We do not want to do like a Python 3 or Perl 6, where we take the community and we cut it in half and we destroy the whole community, where there's like some Go 1 code that works over here and there's some Go 2 code that works over here, but those communities can't use each other's code. You can really, so we want to make sure that I thought at least that all Go 2 code would have to be able to import Go 1 code. But Russ, I think, wants it to even work both ways. So Go 2 code can use Go 1 code, and Go 1 code can use Go 2 code. And how is that really going to work? We don't really know yet. We don't really know what Go 2 is yet, so we can't say how it's going to work. I think, OK, so keep in mind, the Go team is not anti-generics. The community thinks the Go team is anti-generics. I think we all really want them. It's just still an open question about how they get added. And Ian, the guy who did the GCC Go implementation, he's actually written like 5 or 6 generics proposals for Go. And he's implemented several of them to add generics to Go. And he hates all of them, even though he proposed them and he implemented them. But he continues to think about it. So I think that Go 2 will have generics once Ian comes up with a plan. But he thinks a lot about it. People also do not like this in Go. We hear a lot of people complaining. We hear you. There are people thinking about how to make people not have to do this as much. The answer will not be exceptions. We still do not like exceptions for all the original reasons. We don't think error handling for common errors should affect control flow. But we know that this is annoying. But again, there's no plan for any of this. Robert and Ian continue to go through all the bugs on the bug tracker for people that have filed Go 2 bugs, and they look at them. But Go 2 has not really even started yet. And we have said that Go 2 will only have maybe 1 to 3 big changes in it. Maybe one is generics, maybe we don't know. But there will be minor cleanups here and there. Maybe there'll be a new standard library. Like if you can imagine if Go had generics, maybe the standard library is more about algorithms and data structures, and it doesn't have like an SMTP client or other garbage in the standard library. The standard library actually used to have an OpenPGP implementation. It had an NNTP Usenet client. There was even a Space War game that was in the standard library. But we don't really need games in the standard library. And we probably don't need like the net SMTP package or a whole bunch of the other random stuff we have in there. I think especially if we, let's say we had better package management. There's a talk coming up by Brian about Vigo next. And if we had package management figured out, and probably using Vigo, my assumption is that the standard library would use Vigo, and much of the standard library would live elsewhere. So I think we could have a very small standard library in Go 2, But maybe when you download Go2, it comes with cached copies of a bunch of like popular packages or official packages. So maybe like NetHTTP doesn't even live in the standard library. It lives in golang.org/xnethttp2. And maybe if you find a bug or you want a feature, we can add it for you that day, and you can start using it that next day, and you don't have to wait 6 months for a new Go release to come out. That's one thing we don't like about the standard library right now is we have this Go release that comes out every 6 months, but it has like a new garbage collector, it has like a new compiler, and it has a new version of this random package that is not special at all. Like there's nothing special about the HTTP package or, I don't know, like encoding MIME or MIME multipart or something. There's very few packages in the Go standard library that are actually special. There's like the runtime package, parts of time, the net package, things that have to like really hook deep into the runtime. But I think we can get rid of a lot of the standard library, but no promises. People also always want changes to colon equals, and people get confused by it. So maybe something will change there. People always hit this problem where you iterate over a collection with range, and you get this variable v, and then you start a Go routine that uses v. But right now, as Go is defined in the language specification, that is the same v variable for every loop iteration. So when the loop goes around again, it just does a new assignment to v, but that Go routine is already using it, reading it from it, and that's a data race. So you actually have to write like this to get a unique v. And it looks weird. People know what it means nowadays, but it's also kind of unfortunate. And I think .NET or C# changed this like from C# 4 to 5 or something like that. And so maybe we'll change it too. But we also have to consider that if we change a bunch of these minor things, we'll also just confuse people. If they're using a mix of Go1 and Go2 packages, they could make mistakes forgetting which file or which version of the language they're using in which file or which package. So we have to be really careful about which changes we accept, and it has to really be worth it. But that's about the end. Если у вас вопросы, говорите, пожалуйста, по-английски, because I don't really know Russian. But happy to answer any questions.
Так, секундочку. Ребят, передадите микрофон?
Hello, Brad. Thanks a lot for word. My name is Sergey. Sergey. I'm kind of newbie, and I'm from Российская газета. It's Russian magazine which told a lot people about Britain, Great Britain, and so on, about politics. You know that. What do you think? Your son, will he program on Go? Maybe 20 years later. What do you think about that period?
I don't know if he'll program it in Go. I will have to see what a good teaching language is when he's 5 or 6. But I'm hopefully he will learn in a programming language that's like simple and fun. And when I started programming when I was 5 or 6, I started in BASIC, and you can write one line of code and it does something right away. It's not like this language where you need hundreds of pages of auto-generated boilerplate from your IDE, and you don't understand what any line means. So I hope that he learns, I hope that simplicity wins in the end, and there's still a simple option in the future. But we'll see. Maybe it's Go, maybe it's something that's new and more simple.
I see. So next question is simplicity in Go. It's another point. People think it's bad or not that good for развитие, forget this word. What do you think about simplicity of Go? Will it be a stone on the way?
Yes, I mean, simplicity is one of the main features of Go, because Go was created as a response to the increasing complexity of C++. So they needed a balance in the force. You know, for all the complexity in C++, we needed simplicity of Go to like stay sane.
Thank you.
Yeah.
Hey Brad, my name is Dmitry. So the question I would like to ask is, at which point you decided you wanted to have a full HTTP implementation inside standard library?
Yeah, so the question is, at what point did we decide that the standard library should include HTTP? That was actually a very early decision, because every Go program at Google, or I mean, sorry, every program at Google has an RPC client and server, an HTTP client and server. It's just like modern programs with microservices and stuff have to be able to talk across the network to each other. So I think it was decided even before I joined that like the standard library had to include a way to communicate with other programs. So, and then because we did not have internal packages at the time, any dependency of HTTP got added to the standard library. So because we had HTTP in the standard library, we had to have HTTPS, so we had to have TLS, so we had to have X509, so we had to have all this like crypto junk, ASN1. But I think those are all internal implementation details. We don't actually want to have an ASN1 implementation that's public to users in the standard library. We don't want to have an X509 implementation, but we just needed them because HTTPS needed them. So I think we'll probably hide most of that in the standard library and only give you HTTP, but we'll see.
My second question is, how did you decide on error interface? Because there's a lot of discussion inside the community about how to use error properly. And because right now, error is essentially just an interface which says, OK, I'm having error method, which returns a string. So how did you decide on what kind of interface it would be? And are you happy with the decision you made?
I'm happy with some of it. I wasn't super involved with this part. That had pretty much basically been done before I started working on it. But the idea was that the basic thing an error can do is describe itself. And if you want to promise more than that, you have to type assert it to a concrete type of error. And then you can get more information out of it. The problem is we haven't really documented or even decided the rules about when you do this or how you do this. So there's a lot of inconsistency in the community about when they use error variables versus error types, and when they stringify their error message, how much context they include from their own state versus what the caller should prepend to the error message. So yeah, we don't completely like the current situation. And so part of the proposal for people who are working on the whole if error does not equal nil, return error stuff, is also figuring out best practices for returning errors properly and making sure that the best practices are easy to do by default, so you don't have to like teach everybody about it. We want to make it easy to do the right thing, but we don't know what the right thing is yet. And there's many examples in the community of like, the error wrap package, and various Upspin has its own error type, and there's some error types that automatically capture the stack trace for debuggers who want to see like the stack trace for every error. But yeah, there's people thinking about it. There's lots of open bugs too. Or whoever has a mic. Yeah.
Question, hopefully. Alexei Nedionov, IT Labs. We are kind of Russian resettler, and we've been using, I believe we were one of the earliest adopters here in Russia, because we started building our product, telecommunication switch in Go back in 2011. I have a question about garbage collector, because as you mentioned, you did lots of improvement 3 times. It's actually saved us a day 3 times. But still there are a lot of improvements, I believe. We heard about a request-oriented garbage collector, which I believe is kind of generational garbage collector like in Java. So could you please comment, is ROC coming?
Oh, so there was the question is about the garbage collector and like what's coming next. There was an experiment to do something that was called TOC, and then it was renamed to ROC, R-O-C.
Yes. ROC.
I think that experiment mostly failed. It worked until they got to a bunch of the edge. It would have required too many changes to the compiler and teaching it too many things about which system calls are safe on which operating systems. Mm-hmm. And I think they decided it would be a lot of work and a lot of maintenance pain for the benefit it brought. So instead, they're now working on a generational garbage collector.
Oh,
but it's, I don't remember all the details, but it was a non-moving or a non-compacting generational collector that's kind of built on the existing rate barriers that are in Go. But I might be misremembering all this because I was talking to Dimitri about it, and he was like, that doesn't make any sense. So I think there's a document that they're going to publish soon about the details of it.
Okay, thank you.
Yep.
So well, wow. Brett? Yeah, I will give you a chance for the last question, but a small announce. Brett will present this nice Gopher for the best question. So the last question, yep.
Do I get to throw it?
Hi, Brad. My name is Max. And my question is, don't you afraid that if you remove HTTP package from the standard library, you will actually like divide the community?
Yeah.
As it happened with Python and Perl. And if you do this, are you going to leave some interfaces? Like, for example, like currently HTTP handler func takes one parameter by an interface, and we have response, which is a pointer to concrete struct.
Yeah.
And we have tons of middleware that actually uses this concrete struct. Like, are you going to leave some handler func like interface in the standard library so people can write their own implementations but compatible among each other?
The question, in case
Thank
it
you.
wasn't recorded, was are we afraid that if we move net HTTP out of the standard library and move it elsewhere, that we will divide the community and there'll be multiple implementation or multiple users using different HTTP clients and servers, and then all the middleware wouldn't work because it'd be written for the wrong one? And will we have interfaces to make sure that the community agrees on standards? And yes, that is a concern. And I think if we did, and we don't want to divide the community, just like we don't want to pull like a Python 3 or something. So I think if we do something like that, we might have the import path still be net HTTP, but maybe that's an alias for something else. But we will put in common interfaces that we think are best practices and probably have, like, I think the log package needs to be cleaned up a little. Some people want to have the TLS.con be an interface rather than a concrete type because people want alternate TLS implementation. So I think there'll probably be a couple new interfaces added to the standard library, but we are very aware of splitting the community and stuff. And I will say that that was the best question. So you want to go for? Cool. Thank you.
Thank you, Brett.